Now, today we are going to see the counters and comparators instructions here. I delete this one. Now, here that is counter operation. Here also you can see there are counters CTU, CTD, and CTUD. CTU means up counter, CTD means down counter, and up and down counter in a single block. So I drag and drop the CTU on the network here. Here also this counter takes one DB address. Okay, ICE format counter 0 DB. Say okay, is added here. So if you want to use it as an integer or double integer, option is also available. Okay, integer means only 16-bit value. What at maximum will get 999. Okay, value you can count. Okay, whereas if it is double integer, up to 7 nines of value you can count. Okay, so here I take another input M0.1 for reset. You can see PV here. PV means preset value. So here we can give some value like 5 or 10 something. I'm giving 5. So here what happens is when your CV, that is your counted value, is incrementing here, and when the CV value is equal to PV, then your output will be on here. Okay, your output will be on here. So like in schematic manager for S7-1200, it is not comparing PV and CV. PV is for directly setting some value. Okay, from where after that value you can start counting. Okay, but here just it is comparing for 1200 controller. Okay, so here I can take some memory word where I can store the value because we are not having any particular location or address for this. Okay, then here also you can use the counter number like city counter. So which one we want to use? Output Q, that is QU. Okay, that's for up counter. So QU we have to use. Okay, so when PV is equal to the CV value, the Q output will be on. Okay, let's save this and download. I need to close and restart this. Download. Start on. Now I minimize this. The monitor. Now you can see we are having CU input here. Right click, modify to 1. So one value is counted here, right? And right click, modify to 0. And then I count next. You have to make it on and off. So count up. Or so the output is still off here, right? So when I count up again now, so when this becomes equal to 5, you can see output is on. Okay, PV value is equal to your CV, so your output is on. Then this will remain on continuously, even if you are counting up more than 5 also. Okay, so here we are just setting PV for your output, means when it should go on. Okay, that value you can set here. Okay, when it is done. Okay, for that purpose, and you can see the output is also on another output. Instead of using counter, you can use the output also to make another output on simultaneously with this first output. Okay, that's the option here. So when you give this input, reset, modify to 1, reset to 0. Okay, now this for up counter. Similarly, we are having down counter here. You can simply change the counter type here, CTD. This is a down count. Okay, here M 0.1. That is your LD. LD means load. Load input. Okay, so how much value you want to load first? Because to down count, we have to load some value. Some I'm loading value 15 here. Okay, so in PV we have to set. So here it is not comparing here. Okay, but your output will remain on initially. Okay, your output will remain on initially. Now I need to load first. I give this input load value, modify to 1. So what value it has loaded? 15. In your CV you can see 15 is loaded here into CV, and your output is off. When this output will be on? When your CV value becomes equal to 0, right? And when it is less than is it going? Okay, when 14, this is off, right? Now put again. Okay, if we are not having any reset input, means we cannot directly reset to 0 here. We have to down count only. Okay, so like this we have to down count. So first for down counting we have to set the value first, then only we can down count. Okay, so if you set the once it becomes 0 here, your output will become on. Okay, this is how your down counter works. Whereas with up and down counter, CTUD, you can see we're having CU, CD, reset and load. Okay, all the inputs are available here. M0.2 for down count and reset M0.3. Here also, if you want to give some output like Q0.2 something, you can set. CU output is for up counter, QD output is for down counter. But for both, we are having a single memory where it is storing up and down counted values. Okay, so if I give reset input here, right now values there, some values there, it is 11. If I make it to reset to 0, and you can see QD output is on. Here, this is showing true, Q0.2 is on. Okay, and this is off. So when you Modify here. Okay, it is counting up. So when this will be on, when this output will be on, when your CV becomes equal to 15, this QU will be on. Okay, like if I directly load this, see there. Okay, I directly loaded this 15 into CV, so it is comparing here, right? So your QU is on and QD is off. When this QD will be on, when your CV becomes 0. Okay, so there is a difference here. Okay, for CV and CV. So this is about the counters. Next, we are having comparator instructions. Comparator means comparing values. So below counters, we are having comparator operation. I just delete this one. Here I'll take CMP equal to. So this is a view here for your comparator. Okay. So here at the top, I'll give MW2 as an input here. And below, at what value you want to compare, like 5 if I want. When in MW2, which is a CV value, okay, where I'm counting value and storing in MW2, it is changing, right? When it is becoming equal to 5, then your output should be on. Okay, so like this, you can use a comparator. If you want to change a comparator type, you can see the at top corner, you can see green color, okay, triangle. From there, you can select the type of the comparator using symbol. And below is shown for the type, data type, like integer, double integer, real, which data type we are using. You want to compare. Okay. So in a single block itself, it has given the option to select which comparator type and which data type. Okay. Now I'll save the project, download this. The monitor. So here right now value is 15, so it is not equal to 5. That's why your output is condition is false. So output is off, right? You need to count down. Okay. So first what I do is it's a big value, so that many times I have to make on off. I just reset this first. 0. Now 0 is equal to 5. No, right? Now I count up. Modify to 1. Value 1 is there. Then modify to 0. Again modify to 1. You can see that value is changing here. 2 is equal to 5 now, right? So again modify to 1. So like this, you can increment and compare. Next one is equal to 5. You can see condition is true, so output is on. Okay, so like this you can compare the values. Okay, not only by using counter, normal values also you can directly modify and compare. Okay, so this one example I have shown. Now there's one more option you can see in comparator, double equal to. Also it is showing that description. CMP double equal to is equal to symbol. Is a not equal to symbol, right? Less than, greater than symbols are also there. It has given two more options here: in range, out range. In range means within the range. So you can drag and drop this address in value, and minimum value like for 2 and maximum value like for 8. From 2 to 8 your output should be on. Okay, this is in range. Similarly, we are having out range, means out range means control C, control means before like 3 and after 7, like that. Okay, between 3 to 7 it will be off. Okay, so before 3 and after 7 only this output will be on. So 0. Okay, so like this also you can use this comparators in range and out range. There's one more instructions you can see here. Okay, not okay. Okay, check validity and invalidity. That is for checking the status. Okay, type of your real format. Okay, real data type means some real data type means floating point value. If your value is in real format or not, like 50.65 or some real value you are getting, for that one status okay will be on. Okay, for just for status or condition that is used. Now right now value is 5, so it is which is within range 2 to 8, so it is on, and here it is off. If I reset here, the value will become 0, which is less than 3. So this condition is true. This is on. So like this, we can use this in comparator instructions here to compare. Now this is about counters, comparators. Next instruction we have is math functions. In math functions, you can see we are having add, subtract, multiplication, division, mod, okay, negated, okay. So 2's complement means changing the value, or we are having increment block, like that we are having different blocks here. So this block you can directly connect which number you are going to add, integer. So input 1 like MW4 something I take, and MW6 okay. Let's store that in MW sometime. Suppose if I want to add 3 different values, means 3 different inputs, so I can add or increment that, increase the number of inputs here by selecting this star symbol. Okay, this green star symbol is there. Click on this, one more input is added. So you can add like MW8 something. Okay, some memory. Similarly, we are having other instructions. Okay, so I save this, download, load here. Now here I can modify. Select the small line, right click on that, modify. It's going to select modify operand. So here give some value like 55, enter. 55 plus 0, 55. Enter value, some, okay. 55 plus 49 and 99. The purpose of this addition subtraction is like for calculation purpose. Okay, if you are getting some analog value, temperature, pressure, if you have to make some value minus or plus to increase, decrease, or to compare. Okay, so for that we are doing this calculation. Okay, addition, subtraction, multiplication, division. This you can do. If you want to convert a sign also, negative value, input like Control C and Control V and some MW, something like 14 somewhere. So what it will do, it will convert a sign. See, 155 is converted to minus 155. Okay, so like this. Apart from this also we are having converters. Okay, before that we see this calculate also. This calculate, you can make some expressions. Okay, like input 1, input 2. I want one more input. So I give some direct value like 40 and now selected data type, say integer 40 plus 60 divided by 5 something I want to do, and store that in some memory MW20 somewhere. So where is that expression? Okay, I have not written any expression here, right? I gain some values for input 1, input 1, input 3. So to give that expression, double click on the output here. Here we have to give in this order. Example order is there here. So input 1 plus IN2, input 2. So take that in a bracket. Then by input 3. Okay, say okay. So this is a condition. Okay, so like this you can get the expressions here using calculate option. Monitor. Okay, so 40 plus 60 is 100 divided by 5, that is 20. Okay, so like this you can make the expressions here under calculate instruction. So this is about the math instructions here. Another instructions we have conversion operation. So you are already aware of this convert, right? Like BCD to integer, integer to BCD, DI to R, okay? Integer to double integer, okay? So MW22, MD24 something you can use. Another like if you want to convert, okay, whichever data type you want to convert. Even you can convert real to integer directly here. Okay, so MD28 to MW32 something. Okay, so these direct converters are also available here. Whereas in semantic manager, you can see you need to convert integer to double integer and double integer to real. But we are not having real to integer converter, or we have to convert real to double integer by using what? Round, trunc, seal, okay, by those instructions. Okay, like this. operand like 10.5 something converted to 10. Okay, so like this we are using these converters. So floor, trunk, okay, they are having scale X and norm X. This is for scaling purpose here. Round, seal, floor, trunk. Okay, this instruction you can see similar to your schematic manager instructions here. Okay, so we stop here today.